Assalamualaikum and good day, my dear students. So now we are going to continue with topic 13, part 2. So these are some of the formula that we have in this topic. So you can find all these formula in your notes. Please note how to use this formula. For example, we have this formula where set 3 kT over m. We must make sure that this is the mass of one molecule. And these two, they are about the same. The title are about the same, but they have different meaning. F over 2 kT is the average kinetic energy per molecule, whereas F over 2 RT is used when you want to find the average kinetic energy per mole of gas. So it's two different things. Now we move on to the first example. We have question 12 from our facts Q. So A, a 50-liter gas cylinder is filled with 4.2 kilogram nitrogen gas at 25 degrees Celsius. The molar mass of nitrogen is 28 gram per mole. So that is supposed to be negative. Number 1, calculate the pressure of the gas. Okay, so what I would like to do is first I would like to extract all the information that I have. First, this 50 liter, I know that this is the volume. So V is 50 liter. And then 4.2 kg, this is my mass of the gas. Mass of the nitrogen, 4.2 kg. And the temperature is 25 degrees Celsius. 25 degrees Celsius. And I also know that the molar mass is 28 gram per mole. So Mr is equal to 28 gram per mole. Number 1, I need to find the pressure of the gas. Okay, so straight away I know that I have to use PV and RT, but do note that my quantities of volume and temperature are not at the right unit. So 50 liters, we convert it into meter cube. 1 liter is equivalent to 1 times 10 power of negative 3 meter cube. Therefore, from liter to meter cube, it will be 50 times 10 to the power of negative 3 meter cube. And as for the temperature, we have to plus it by 273.15. And we will get 298.15 Kelvin. Okay, so from our PV and RT, our N is number of mole, and I know that number of mole is equal to the mass over molar mass. So I can substitute the number of mole with mass over molar mass. So my formula becomes PV equal to MRT over MR. And then the question asks us to find the pressure. So pressure is equal to mass molar gas constant multiplied by the time over molar mass multiplied by the volume. Okay, so we need to substitute all the everything in this equation. So the mass is 4.2 kg and molar gas constant is 8.31. Temperature is 298.15. Okay, over our molar mass. We also have to convert it into kg per mole because our mass is in kg. Okay, so this is equivalent to 28 times 10 power of negative 3 kg per mole. Okay, so this is 28 times 10 to the power of negative 3. And our volume is 50 times 10 to the power of negative 3. Okay, and here we should get 74.33 times 10 to the power of 6 Pascal. Okay, sorry, it's supposed to be 7.43, not 74.33. It's 7.43 times 10 to the power of 6 Pascal. Okay, so that's the first part of the question. And second, if the gas pressure drops to 250 kilopascal, calculate the remaining mass of the gas. Okay, so what I can imagine is some of the nitrogen gas was leaking. Okay, so the molecule the molecule gets out of the gas cylinder. and so we have less nitrogen gas in the cylinder, and therefore the pressure drops, and also the remaining mass would be less than what it initially have. Okay, again, we can use our PV nRT. Okay, so the second part of the question, I'll use blue color. PV is equal to nRT. Okay, you can find what is the remaining number of mole. So N is equal to PV over RT, and the pressure has become 250 kilopascal. And then the volume will remain the same because the shape or the size of the cylinder doesn't change. And our molar gas constant is 8.31, and the temperature also doesn't change. So 298.15 Kelvin. And here we will have 5.05 mole. Okay, so when we have the number of mole, we can find what is the mass, which is the mass is equal to the number of mole multiplied by the molar mass. Okay, which is 5.05 multiplied by 28 gram per mole. So if we use gram per mole, we will have our final answer in gram. If we use kg per mole, we will have the final answer in kg. So here I am using gram per mole. So I will have the final answer as 141.4 gram. Okay, so that is part A of the question. Part B of the question, the molar mass of oxygen is 32 gram per mole at 300 Kelvin. Calculate number 1, the root mean square speed of the oxygen molecule. Okay, so Mr is equal to 32 gram per mole, and then my temperature is 300 Kelvin. Okay, first part of the question asks us to find the root mean square speed of the molecule. So number 1, we can use this formula, VRMS equal to 3 RT over the molar mass. Okay, we use this formula because we have the temperature and also the molar mass. So 3 multiplied by 8.31 multiplied by the temperature. It is already in Kelvin, so that is quite convenient for us. And when we are using this formula, we have to make sure that our molar mass is in kg per mole. So it is 32 times 10 power of negative 3 kg per mole. Okay, so over 32 times 10 power of negative 3. And here we will have 483.44 meter per second. Okay, and then the second part of the question, what is the internal energy of 3 mole of oxygen? All right, so to find internal energy, the formula is U equal to F over 2 nRT. Okay, because we have the number of mole, and we know that oxygen, it is a diatomic molecule. Okay, the atomic notation is O2, which means it has 2 atoms, and we know that the degree of freedom of the atomic molecule or atoms is 5. Okay, so use that F equal to 5 into our equation. So this becomes 5 over 2. Then our number of mole is 3. This is 8.31 multiplied by the temperature 300 Kelvin. Here we will get 1.87 times 10 to the power of 4 joule. Okay. So the next example is from question number 15. Okay. Question number 15A, number 2, calculate the volume of 2 moles of neon gas at a temperature of 305 Kelvin and a pressure of 1.2 times 10 to the power of 5 Pascal. So the question asks us to find the volume. Okay, 2 moles of neon gas. So our N is 2, and then neon is a monoatomic gas, so it has a degree of freedom of 3, and then temperature is 305 Kelvin, And finally, the pressure is 1.2 times 10 to the power of 5 Pascal. Okay, so what is the volume? So we can use our ideal gas equation again. PV is equal to nRT. So we need to find the volume. So V is equal to nRT over the pressure. And our number of mole is 2 multiplied by 8.31 multiplied by the temperature, which is already in Kelvin, and divided by the pressure, which must be in Pascal. So here we get 0.0422 meter cube, okay, or 42.2 liter, right? Next is B, a flask of volume 5 times 10 power of -4 meter cube, okay, this is the volume, contain oxygen gas, alright, so this is our atom, at a pressure 2 times 10 power of 5 Pascal and temperature 300 Kelvin. Determine number 1, okay, the number of molecules in the flask, right? So again, I would like to extract my information. My volume is 5 times 10 power of -4 meter cube. And then this is oxygen gas, again, a diatomic molecule. The degree of freedom is 5. Pressure is 2 times 10 to the power of 5 Pascal. And then the temperature is 300 Kelvin. Okay. First part of the question asks us to find what is the number of molecule, our capital N. Okay. So using our PVNRT, or we can straight away use PVNKT actually. PV is equal to NKT, where N is our number of molecule. So N is equal to PV over KT, and the pressure is 2 times 10 to the power of 5. Then our volume is 5 times 10 to the power of -4 over K is Boltzmann constant, 1.38 times 10 to the power of -23, and the temperature is 300 Kelvin. So here we will get 2.41 times 10 to the power of 22 molecules. Okay, so that is the first part. And number 2, what is the density of the gas? Okay, let's use a different color now. So right now we have the number of molecule. Okay, we can find what is the mass. Okay, we know that number of mole is equal to the mass, sorry, this is supposed to be the mass, okay, mass over molar mass, and also number of mole also equal to number of molecule over the Avogadro constant. So equating these two equations, right, since we have the molar mass here, 32 gram per mole, okay, we can find what is the mass of the oxygen gas in the flask. So equating these two equations, so M over Mr is equal to N over Na. So M is equal to the number of molecule multiplied by the molar mass over the Avogadro constant, and then we substitute our number of molecule, 2.41 times 10 power of 22 multiplied by the molar mass. Okay, but the molar mass, if you want the answer in kg, you must convert it into kg per mole. So this one becomes 32 times 10 power of -3. Then over our Avogadro constant, 6.02 times 10 power of 23. Okay, so here we will get 1.28 times 10 power of -3 kg. Alright, so since we have the mass, we can find what is the density. So density is equal to the mass over volume, and we already have the volume, which is 5 times 10 power of -4. So this is 1.28 times 10 power of -3 over the volume, which is 5 times 10 power of negative 4 meter cube, and here we will get 2.57 kg per meter cube. Alright, and lastly, what is the root mean square speed of the gas, right? So since we have the density, we have the pressure, we can use this formula, which is Vrms equal to set 3p over rho. Then just substitute our values. 3 and our pressure is 2 times 10 power of 5. Okay, 2 times 10 to the power of 5 Pascal. And density that we have just calculated just now is 2.57 kg per meter cube. And here we will get 483.18 meter per second. Okay, so depending on how you press your calculator, you will have slightly different values, but that is just about how we do it. That's the step to tackle this question. Okay, so I hope you learned something from this video. All the best in your exam. Thank you and bye bye. Assalamualaikum warahmatullahi wabarakatuh.